Suppose I were to tell you that you can actually smell better than a dog. Would you believe me? Probably not. Would it surprise you if I told you that if you drink your tea in a red colored mug, it will taste sweeter than in a white mug? And would it blow your mind if I told you that as much as you hate airline food, using a saline nasal spray before eating and wearing a really good noise cancelling headphones will improve the taste of airline food? Welcome to the fascinating science of flavor. Let's start with an equation. Flavor equals taste plus smell plus sound plus sensation plus sight multiplied by nostalgia. Let's start with taste because it's a word we tend to use interchangeably with flavor, but in reality, it only represents 10 to 15% of the perception of flavor. Taste is detected by thousands of taste buds on your tongue. Some people have fewer taste buds and some people have more. The ones who have a lot are called super tasters. And while 35% of women are super tasters, only 15% of men are super tasters. So when women tell us men that we don't have good taste, it is quite literally true. On average, men tend to have fewer taste buds. A common myth is that different parts of the tongue have taste buds dedicated to detecting different tastes. That is not how it works. A single taste bud is made up of 50 to 100 taste cells, and each of these cells can respond to different tastes. When the cells detect and respond to sugars, they trigger the brain to give you a sweet sensation. When they detect protons, hydrogen ions, you get a sour taste. When they detect alkaloids, you get bitter. When they detect sodium, you get salty. And finally, when they detect glutamates from MSG, you get the savory umami sensation. So taste buds can detect all tastes, and depending on what you eat, your brain will make sense of these signals and in some cases highlight or mute some taste experiences. And this is something good chefs have always known intuitively. For example, adding a tiny bit of sugar to your dal or chicken curry amplifies other tastes. Likewise, adding a little bit of salt to your desserts amplifies sweetness, and umami amplifies all other tastes. At the same time, sweet can also suppress sour, and sour can suppress sweet. Let me give you an example you will all be very familiar with. You eat amla, gooseberry. It's very sour because it has citric acid. Acids donate protons, and protons trigger the sour taste buds. So when you see an ingredient that has acid in its name, it is going to be sour. Lactic acid in curd, tartaric acid in tamarind, etc. So back to citric acid in amla, it triggers the sour taste cells. But the citric acid molecule also triggers sweet, but not as well as sour. So you eat amla and then drink water, the water dilutes the acid, so the sour receptors turn off while the sweet detectors are still working. So your brain switches to telling you that it's now sweet. On a side note, always remember that flavor experiences do not happen in the mouth. The chemistry happens there. The experience happens in the brain. And our brains are easily tricked. So that is taste. It's only 10 to 15% of the perception of flavor. Let's get to the big boss of flavor, aroma. Remember what I said about humans smelling better than dogs? Let me convince you how. Dogs and most other mammals are fantastic at smelling things from the outside in. In fact, a dog's head with its long snout is designed to smell the smallest trace of certain molecules. But here's the catch. Dogs do not smell very well as they breathe out. And you might ask, what's the point of that? Isn't the only goal of smelling to detect stuff on the outside? And the surprising counterintuitive answer is no. And the reason for that is fire. You see, early human beings who discovered fire subsequently also discovered that raw food plus fire equals delicious and more easily digestible food. Cooking breaks down large molecules into small, easily digestible ones. And that allowed humans to evolve larger brains because we did not have to use most of our energy just digesting raw food as all other animals do. So cooking is what makes us uniquely human. And a side effect of that is the evolution of sensors inside our nose purely for detecting aromas in food. Dogs don't care about detecting cinnamaldehyde from cinnamon in your biryani. But when you chew food, spice molecules get released and travel to the back of your mouth. And as you breathe out, they get detected by your nose. And remember, cooked food has smaller sized molecules. Smaller molecules are volatile and can be detected by your nose. This is called retronasal olfaction. And no animal does this better than humans because we cook our food. And we can detect more than 10,000 different molecules. Again, women on average smell better than men do. We can tell the difference between soft and cumin, between green cardamom and black cardamom, between saffron and turmeric. Not because we smell it from the outside in, but from the inside out. This is why when you have a cold, your olfactory receptors are blocked and food tastes terrible. Smell is 80% of flavor. This is also why when you're sick, your mother or grandmother likely made you food that was salty or sour, like rasam or khichdi, or high on umami, like chicken or mutton soup, because only your tongue works when you're sick. Which brings us to the terrible experience of airline food. The pressure inside your cabin is lower than atmospheric pressure. This is done to reduce the stress on the structure of the plane. And your nose and taste buds don't work very well at lower pressures. Secondly, the humidity inside the cabin is very low. This is done to prevent fungal and bacterial growth. Planes carry thousands of people every single day. So keeping the humidity low reduces microbial contamination. And in low humidity, your nose does not work very well. So if you spray your nose with a saline spray before you eat, a wet nose is better at detecting aromas in food. Which then brings us to the noise-cancelling headphones. How does that work, you might wonder? And that is the third component of flavor, sound. Ancient humans used the crunching sound of biting into an apple as an indicator of freshness. This is why we like crisp and crunchy textures. Soft and mushy sometimes signal rotting, while crunchy suggests low moisture and thus freshness. In an airplane, the engine white noise blankets your soundscape, so you're not able to hear the sound of yourself munching on food. So if you wear noise-cancelling headphones, you will be able to enjoy your food better. By the way, business class gives you noise-cancelling headphones, which is why people will say business class food is so much better. It's usually the same food cooked in the same kitchen, but it's quieter in business class and noise-cancelling headphones. So the next time you salivate, the moment you hear a sizzling sound or sigh at the satisfying crunch of a potato chip, thank your ears for that flavor experience. And that brings us to the trigeminal nervous system, which has millions of nerve receptors inside your mouth to detect things like heat, cold, sharpness, etc. This is to prevent you from eating things that could damage you physically. Bitter taste buds detect alkaloids, which can be poisonous, but taste buds will not tell you if your food is boiling hot. That is what nerve receptors do. Fun fact, the TRPV1 receptor that detects high temperature is the one that is tricked by a molecule called capsaicin in chilies. This is why chilies give you the illusion of heat. This is also why we use the word hot to describe chilies. Although, when we eat them, they are at room temperature. And menthol in mint tricks the TRPM8 cold detection receptor, so you get that chill sensation when you eat mint. There are also receptors to detect texture. Is what you're eating soft, slimy, doughy, rough, nutty, crunchy, or crisp? Texture is another critical element of flavor. Most people find a mix of textures to be more interesting than food that is just one texture. Watch my video on Maharashtrian food to understand how some cuisines in India offer a multi-textural experience by design. We also like contrasts. For instance, when it's raining, everything is cold, wet, and soggy. So we enjoy the opposite. we enjoy hot, crisp bhajiyas, pakodas. They offer contrasting textures to the weather. And then we have sight. Remember the red colored mug? Our brains have, over the years, learned to associate certain colors with certain tastes. Yellow signals sour because citrus fruits tend to be yellow-orange. Green signals bitter because leafy vegetables taste bitter. And red suggests sweet because ripe fruits tend to be red because they lose green chlorophyll and add red carotenoids as they ripen. So when you drink tea from a red mug, it feels sweeter than it actually is. So you can use this to your advantage. If you use a red mug, you can get away with smaller amounts of sugar, and that is good for you. There is an interesting experiment that demonstrates how we associate flavors to colors quite strongly. If you take strawberry flavored candy and lemon flavored candy, our brains expect the former to be red and the latter to be yellow. It turns out that if you switch the colors, meaning make a yellow colored strawberry flavored candy and vice versa, your brain will get thoroughly confused. This has been demonstrated many times. And finally, we have this mysterious nostalgia factor that seems to multiply all the other components of flavor. Because flavor is a multi-dimensional experience, we use the limbic system to store flavor memories. The nose is directly connected to the limbic system in our brains, which processes emotion and memory. This is why when you eat certain foods, they can quite literally transport you back to a specific time and place, like your grandmother's kitchen. If what you eat evokes those memories, then the experience of flavor is hugely amplified. This, in a sense, is how comfort food works. The dish might be a simple dal roti or a fish curry and rice, but if it evokes a strong nostalgia factor, you will find it delicious. This is why it's hard to enjoy chaat in a 5-star fine dining setting. The chef might be astonishingly talented and make the most multi-textured and richly flavored chaat, but if it does not evoke past memories of you enjoying it in a street side shop with your friends, it will not have the same flavor impact. This is also why people find it very hard to eat dishes they grew up eating at home elsewhere. This is why North Indians find chapati dal in Chennai or Kochi to not taste good to them. It tastes fine, but it does not evoke that individual's nostalgia. This is also why South Indians get upset when they see Szechuan dosa in Mumbai. Their nostalgia of simple, home-cooked dosa gets in the way of being able to appreciate novelty. Turns out, it's very difficult to appreciate culinary novelty in dishes we grew up eating. And in a sense, understanding all of this should give you a deeper insight. It is nearly impossible to be objective about reviewing food. When people leave negative comments about a restaurant, they might say the food was terrible, but more often than not, they are actually saying the food was unfamiliar. It did not evoke my nostalgia. So enjoy food. We don't just eat with our mouths, but with all our senses.